Hello everyone. First and foremost, I welcome you all to this training of AWS cloud services. Firstly, before we entering into the cloud services technology, let me brief you on what actually an OS is. It refers to an operating system. So we all must be knowing that to perform any computing services, we require an OS, that is an operating system. It could be of any flavor, that is could be of Linux, it could be of Windows, or it can be of Mac. And even mobile is also a server, is also a system in which we'll be using Android. Okay. So for any computing services, we use an operating system. In the Linux, we have multiple flavors of Linux operating system. We have Red Hat, and we have multiple versions in the Red Hat like 6, Red Hat 6, Red Hat 7, and Red Hat 8. And we have Ubuntu, similarly CentOS, Fedora, and we have multiple operating systems, multiple flavors in Linux operating system. So to perform any computing services, we use an operating system. We use an operating system. So in the same way, and this operating system is also be said as a server. And we will also use the operating system or the server to launch any of the applications in similar to, like we all must be using some of the applications on our daily basis, which includes WhatsApp, Facebook, Instagram, or like many other applications that includes for shopping needs and all, like Amazon and all, Amazon, Flipkart. So we use these kind of similar applications on our daily basis. So in order to use this application or make availability to the customers or the consumers, all these applications are to be hosted in a server. It could be on any of the operating system. So like for each operating system, the process would be different, but the use case and the application functionalities and the behavior would be same, even if you launch an applications in multiple operating systems. So, and there are multiple scenarios and multiple techniques that we can use to launch an application in a server. Like mostly we have three techniques. We have three techniques to launch an application. That includes, one is bare metal. One is bare metal, and the second is virtualization, and the third is cloud computing, or we can also say cloud technique, because the computing includes in all the way. Like we perform the computing services in even all both above, in the both above. So The bare metal refers to the actual desktop or the laptop that we currently use, or we can also call it as the physical devices, the physical hardwares. The laptop that I'm using, or the desktop, or the PC that you are using currently, even for listening to this class, or like to practice any of the computing services, that all comes under bare metal. Like if it could be a desktop, it could be a PC or laptop. So these all comes under the bare metal. We can launch an application directly into a bare metal. Like it could be of any of the application. We can launch that particular application in any of these two devices, which are considered to be bare metal. In similarly, we have virtualization. So virtualization is even similar to the bare metal, but see, if in the bare metal, like we can only be used one operating system. It could be of Windows or Linux, any flavor of Linux or Mac. So we can only able to use one particular operating system per an instant. Like we can install the other operating system and we can use it in the bare metal. But each time we can only use one particular operating system in the bare metal. And if there are any use cases to use multiple operating system in a single uh, server or in a single operating system, if we could say, so in that case we use a technique called virtualization. So the virtualization refers that using multiple operating system in a single operating system. See, even here, for for implementing the virtualization technique, we need the bare metal. So without bare metal, we can't host any of the virtualization technique or any of the operating system in that particular virtualization platform. So in current markets, like to implement the virtualization technique, we mostly use VirtualBox and a VMware workstation. So we use these VirtualBox and VMware workstations to configure multiple operating systems in a single, we can say, of server or single operating system, single bare metal, we can say. So I can show you what actually the VirtualBox looks like. So Oracle VirtualBox. So here, if you could see, I have we have four operating systems here. Like in a single bare metal, if I open this particular RHEL8, this is completely is an operating system, an individual operating system. And this is the other operating system. Like for an use case of using multiple operating system, I just cloned this to use two operating system for a practice. So, and this mini cube is for we to use a Kubernetes cluster to set up a Kubernetes cluster, and this mini shift is used for a OpenShift cluster. So I have configured four operating systems here. So in a single operating system, if I log in and if I start this particular operating system, I can log in. I log in into completely a different operating system. And if I start this operating system and I log in into a complete different operating system. So these are four individual operating systems. So this is where we use the virtualization technique. And in similar way, cloud computing is also refers to the same. Even these cloud computing platform is hosted on the bare metal, but which what makes difference here is these are here in the cloud computing system, like if in the bare metal and the virtualization, the computing services are managed through physical devices. Through, through physical devices. The computing services are completely managed through physical services. So here we require CPU, desktop, or PC, and RAM as per the requirement. We need the power connectivity and many resources as per the project or the infra that we create. So in both bare metal and the virtualization technique, the computing services are managed through physical devices. But here in cloud computing, the complete computing services are managed, or we can say delivered through internet. So here, this is the main point that makes difference in from three of these techniques. In the above two techniques, the cloud computing services are completely managed and delivered through physical devices. But here in cloud computing, the computing services are completely managed or delivered through internet. So I'll just make you clear understanding on what actually this the difference between all of these three. Let me like take another tab. So as I mentioned before, the difference between all those three. See, to launch an application, let's consider as like we've been using Insta these days for a long time on our daily basis. Let me take an application of let's say an Instagram as an application. So let me take this is an application. Let's take this as an application, and let me take this is our server or bare. Let's consider it is a bare metal. So this is our bare metal. Yeah. So this is our bare metal, and this is Insta. If the requirement is to launch or host, the requirement is to launch or host this particular application into bare metal, then there we require for this particular resource, there we require CPU, we require RAM, we require a power socket, and for if it is like if for the internet connectivity, we can use the routers or LANs, switches, and the multiple devices for the net connectivity or the internet connectivity. So if we really launch this particular application into a bare metal, and this can also be considered for virtualization too. The same can be considered. The same can be considered for the same can be considered for virtualization technique for both. So what I'm referring to is what I'm referring to will be considered for the both. See. So if I launch this particular application into a bare metal or to a virtualization technique, there we have a requirement of like uh, we have a requirement of CPU, and we need a requirement of we have a requirement of power connectivity. Like, to make clear understanding, let me write this is this is this is CPU, this is RAM, and this is completely power supply. See, if we have the minimum requirement of resources for a physical device to launch an application is CPU, RAM, power connectivity, and also the internet connectivity. Let's consider net connectivity. Okay, these four are the minimum requirements that an operating system should have to launch, to run, or to perform any computing services. Even if it's not launching an application, like even if it is a even to perform any simple computing services, the minimum requirement of resources are these four. And if I really launch this application into a bare metal or the virtualization technique, then continuously these resources should be provided to the server. So only then the application will be up and running continuously. And the user can only access to an application only when the application is up and running. So if there is a failure of any of these particular resources, if there is a if there is a latency in the network connectivity, or if there is an intermittent connectivity issues in the network, then the application will be down. Or if there are any, if the CPU goes to 100% by with the utilization of any other resources in the same operating system or same bare metal, then the application goes down since the server gets crashed. The, the server gets crashed, and the application goes down. Or if the RAM utilization is 100%, like if you are using multiple tabs or multiple applications simultaneously, so there must be a chance of high RAM utilization. And if the RAM utilization goes to 100%, then it affects or impacts the other applications running in the same server. And if there is any power connectivity, so like we can't guarantee the 100% or the zero downtime in the power connectivity. So if there is any single failure in any of these four resources, these are the minimum requirement, like based on the application or based on the infra that we create, the resources gets increased. And so if there is any single failure in these four particular devices, then the definite impact would be on the application. The application gets down, and if the application gets down, the clients or the consumers will be interrupted from their work. Like whatever the current work they've been using, they'll get interrupted. So if these happens for multiple times, then there is a chance of huge business loss for the application. Like if we currently if we choose the Instagram, so if you're talking to someone or if you're chatting to someone, if it's interrupted in if it's interrupted in middle of your work, then the user definitely opt for the other application to use, which is which is having the zero downtime. or which is not having this the similar issues what we'll be facing in Instagram. So in this way, there would be a huge business loss for the application if we launch in it in the bare metal or the virtualization technique. So this is the one use case that we have when we launch an application in the physical device, like the bare metal or the virtualization that completely refers to the physical devices. And in the second point, so however, if we launch this application in the physical devices, then if today there might be 100 users using this application, and if something it gets viral, or if the user experience is more than expected, then definitely these 100 people would refer few others to use it. Like if we hear the people around him, the people around them, they'll definitely refer about this application and the use cases that they have in the application. So there might be a chance of getting 500 users the next day. But we don't use the infinite CPU or the infinite RAM or the infinite power. Like we can't use, we don't have a facility of using them for infinite. So if we use like 4 core CPU, and if we use 32 GB of RAM, so there might be a 100 users today who can completely experience the application with these particular resources. So the application can manage 100 requests, 100 clients for the resources it's been configured. That is like 4 core 32 GB. So in case if we have 500 users the next day, or the 1,000 users, or the 10,000 users in the coming days, or after soon after they launch the application, then these configuration couldn't help the application to provide the same features or the functionalities to 1,000 people or 10,000 consumers. So there there would be a requirement of increasing the resource. So this comes this comes under the topic of scaling. So when we'll be into the topic of scaling, then we'll be referring it there. We'll learn deeper into it. So this is called this is called the it is also called a scaling technique. So it can also refer to vertical scaling, like increasing the physical devices. Okay, so if there is a requirement of 4 core, since it is a physical device that we are referring, so there might be one CPU with four core. And if there is a requirement of having 8 cores, then we need to add one more device of 4 core. We can't make 4 core to 8 core here, since it is a physical device. So we can't update a physical device, right? Like, so if we have 4 core CPU, then to obtain 8 core, we need to add one more 4 core CPU in addition to it to make it 8 core. In same way, if we have a requirement of adding 16 more GB to the RAM, then we need to add one more physical device, one more physical RAM having 16 GB storage, having 16 GB memory. So only then the application can provide the functionalities to the increased clients or the increased consumers. So in this way, we'll be continuously adding the devices as per the consumers or the clients increases. So this is the other challenge that we have here. Like, so this is the other challenge we'll be having when we launch the application in a physical drive. So this is the second thing that we have. And like if like we are as we are moving forward in the training, we'll be adding multiple points that we have the limitations in the physical devices and the benefits in the cloud computing technique. So in similar to it, so if we talk about the other third technique that we have, which is cloud computing. It's cloud computing. Like see, like if we have here it, then we'll take it cloud computing here. So just to have the comparison between the both. So if we take cloud computing technique. So here, as we just mentioned, in the cloud computing, the computing tech services, all the computing techniques are managed through internet. So here we have multiple platforms in the cloud computing services. I'm not referring to AWS here directly, like in the initial overview, we have multiple cloud platforms like AWS from Amazon and Azure from Microsoft and GCP from Google. And we also have IBM Cloud and some other like Alibaba Cloud from China. And we have Oracle. We have multiple cloud platforms. So we'll use according to the infra that we needed for the project. And also we use based on the support that the providers, the cloud providers provide, and the billing for the resources that are required as per the project we have. So we have these multiple cloud platforms to implement the cloud computing services. As we are completely into the AWS training, so I'll take you the examples of AWS, so which makes relative to the coming session, so that you'll be knowing that you are aware of that particular resources. Okay, so here in the AWS, in similar to have a server, same as an operating system like Red Hat that we have in the uh, bare metal or in the virtualization. Here we have EC2 instance. So when we launch this particular EC2 instance, so let me take let me highlight it with this. So an EC2 instance. So when we launch an EC2 instance, when we the complete our network will be managed to the platform just to open the console of AWS. Our network traffic, our network traffic use case is to just to open the console until the AWS console accessed or opened. Only in these operation our network will be involved. Our network will be involved. So when we open this console and launch an EC2 instance, then even if the power or even if the connectivity goes to our particular bare metal or the operating system, the the server gets launched, because when we as soon as we launch the EC2, the complete network and the yeah, all the resources that an server required, same as RAM, CPU, so all this network, all this will be managed through the AWS network. uh, in the process of launching the EC2 server, we configure all its details. We all configure with the image that we use. Image is nothing but the flavor. If it like it could be Red Hat, Ubuntu, Fedora, CentOS, Windows. In a similar way, like we can have any like Amazon Linux and all. we can have any of the image. We'll choose the platform and we'll choose the RAM, CPU. So, and these are like we have multiple options when we go to when we are talking about the EC2, we all get to know what options that we have for an operating system for launching a EC2 server. So we'll provide all these details to launch an EC2 instance there, and after configuring all the details, and soon after we launch an EC2 server, the complete traffic and the network will be managed by AWS. So here, if there is any connectivity issue or if there is any issue with the network or the LAN or the Wi-Fi, then it wouldn't impact to the EC2 server. As we'll make the server to stop state, the EC2 instance completely keeps running in the background. So when we launch an application to this EC2 instance, then only there could be one chance of being the application down only when we stop the server. And even if you start this EC2 instance and if you close the console and if you close the operating system or you will shut down your operating system, then that doesn't impact any connectivity or any other impact to make this server down. It wouldn't impact any way to make this server down. Only when the server goes down is if we manually stop the server. Only then this gets down. So even if we close the console or even if we shut down the bare metal, that wouldn't impact any way to this EC2 instance. So if you get to know what actually I referred, if we launch the application into this EC2 instance and if we don't stop it, then the application continuously in the upstate. So the user wouldn't get any manual interruption while he's experiencing that particular application. So this is the one advantage makes difference from the below below techniques from this. And the second that we referred in the physical is like if there is any requirement of clients increased clients or the increased consumers within a period of time, then there might be a requirement of CPU increase in CPU, increase in RAM and all. So here, since it is completely managed through internet, we have an option of upgrading the CPU, upgrading the RAM to the existing server. So as soon as we claim a request to increase the CPU and to increase the RAM, the CPU and or the RAM's size can be upgraded or increased even for the existing server. So, and this is the other advantage or the benefit from the below technique in comparison to below technique. So these are the main differences that we have in both. Also, if we could add, even it refers to the same for before. See, it is scaling up, scale up. So we are increasing the resources, and we also have the scale down. So we have like for only one particular period of time, if there is a use case of increasing RAM. So if we could talk about the Hotstar or any other applications, so there, like if there is a match between the see, and also when we comes to billing here, like in the physical devices, we completely own the devices. Like we'll completely buy the infrastructure, even if it is CPU, even if it is RAM, Wi-Fi router, switches, power sockets, all the devices that we own ourselves. Like we'll buy the infrastructure. So that is where the cost of infrastructure will be more. in buying all the resources. But here we don't own the resources. We just pay the rent as like there is a terminology called pay as you go. Pay as go. Like the complete AWS team will be owning the resources, and we use their services, and we pay as we use the resources as a rent. So this is where the billing is about. The billing of resources is about. And in the scaling down process, so if you refer to the Hotstar, if there is any match between India and Pakistan, so there might be a chance of high streaming count, like higher count streaming the live match. There could be 4 CR, 3 CR, 3 crore people or 4 crore people watching this India versus Pakistan match. So there it needs more RAM. So if we have increased like if it is like 1 TB RAM, like it wouldn't be 1 TB, like just to have 1 TB is a lot more RAM it refers to. So if we have 1 TB of RAM for the live streaming of this particular match, India versus Pakistan, then so there we require 1 TB. So we'll be paying the bill of 1 TB for that period of time we use until the match. And if it is continuously, if we have the 1 TB for long time, then the bill would be pretty larger as expect the as we as the clients or the as the consumers use. So then the next day after these match there would be some other matches like we are not currently referring to any of the name. So there could be of matches where only 1 CR people can watch after this particular match. So there even if we use the same RAM of 1 TB, but it would be used only like if 100 GB of RAM for these particular viewership. Then the 900 GB, which is similar, not equal to 900 GB of RAM is like it's not been used by us, but it will be counted on the billing. So where the complete loss for the infrastructure that we create would be occur. So here there is a chance of decreasing then we can only make this RAM to 900. But if we see this, if we compare it with the physical infrastructure and the cloud infrastructure, if we buy 1 TB of RAM for this particular match, then we can't give it back to the shop or we can't give it back to the uh, retailer, the distributor again. Like you can't take it back after our use, right? Like if we go to the distributor and the retailer and say like we don't require this GB now, so we are just returning you back, so they can't give our money back and they don't take their item uh, back. So here if once we invest the 1 TB of RAM, then we shouldn't we don't have any way to uh, uh, like uh, return to the distributor or the return to retailer. So then we are having 1 TB of RAM, but we don't use 1 TB of RAM. So this is where like our infra and the cost of infrastructures will be more. But here in the cloud, there is a option or there is a feature of decreasing the RAM. So then after using the 1 TB, so we can from the next day we can only degrade these to 100 GB so that we can only pay the billing for 100 GB RAM. So by this way we can able to reduce the cost of this 900 GB. So here we have the flexibility of increasing when required and decreasing when it's not. This is the other use case that we have. from the EC2, from the cloud computing services, and the physical computing services. So these are the main use case for evolution of cloud computing services. And there are many other use cases for the evolution, but this is the main root root reason for the evolution of cloud computing services. So if you're talking about it AWS, but just to ensure what it actually do in the behind scenes when we launch an EC2 instance, the AWS team have, even they use the physical devices in the behind scenes, but here we don't own the complete resources for our infra. They own their infra, but like they will be hosting their multiple data centers in multiple regions, like they have in the California, they have in the even they have in the Hyderabad, they have in the Mumbai, they have in the Oregon, like they have southeast and south west for the multiple regions they have multiple data centers. So when we launch an EC2 instance, they'll spin up one of the server physically on the data centers, and when we degrade it, then they'll shut down their particular server on their data centers. So this is how this cloud computing technique works. Just to talk about the multiple regions that we have in the multiple techniques that we have on the AWS cloud platform is like we have in the North America. In the North America, we have on the Oregon. In Oregon, like we have 4 availability zones. So we'll talk about the availability zones later. So these are the regions. These are the regions of the data centers. California, and they have US West, Canada, Virginia, and Ohio. And this is referred to be the planning. They're planning to implement create a data center there. This option refers to coming soon, and these are the current existing regions. And if you talk about the Asia Pacific, so we have in Hyderabad, we have in Mumbai, we have in Incheon, Beijing, Hong Kong, and these are Thailand and Malaysia. They're planning soon in Thailand and Malaysia. So these are the multiple regions they are they have created the data centers, and there is also a reason for launching it in multiple regions in every country. So the reason is like from country to country. There when we this will be talk about, like will be elaborate more when it comes to the availability, high availability. And see, like if there is a requirement of launching a server or using the platforms in 2 different regions, like if there should be a connectivity between two and there is also other reason, the other benefit of using cloud computing, like if as we are moving forward, we'll get to know multiple points, and there will be talking about uh, the benefits and all between the cloud computing and this. And the other point that I would like to add here is, if there is a requirement that let's consider it as a thought point. If there is a requirement of connecting one server to other server, see, if you have if there is a requirement of sharing, like on daily basis we will be sharing the movies and all from our mobile to our laptop, in a similar way, like to visit, to view the movies or to view any of the media platforms, will will be transferring the media from one device to other media. So just to have this just to have this transferring the media from one device to another device, there must be one there must be a physical connection between the two devices. Either it can be through wire or through Bluetooth and network and anything. So there must be a physical connection between the devices to transfer the media or to have the connectivity between both. So if we are using the physical devices, if there is a laptop in India and there is other laptop in America, so how can we connect these two devices? So through wire we can't connect two devices. Like we can't have a wire from India to the America, and we can't connect it through Bluetooth. We can't connect it through Bluetooth. So in this use case, if there is a connectivity, if there is a requirement of connectivity between both two countries, the devices are in the two different countries, then we can only connect through internet network. But there will be multiple policies between these two countries. There will be some policies and some agreements between the two countries. So there might be some of the countries that can't allow the traffic or allow the network uh, from one some of the specific countries. Like if you talk about the China or Pakistan, there might be of some policies that they don't allow the traffic from India. If let's say, then if we have the data AWS data centers only in India and only in if America, then if the client's requirement is to connect from India to America, then eh, the governments or any of the third party services that provide the connectivity, there might be of chances of agreeing or disagreeing their opinion of AWS. So there might be some problem, so in which they can't build a connectivity between both the regions. So for that reason, so if it is owned by this particular owner, if they're having the data center in these two regions, then they can easily have the information of uh, both the countries and both the data centers, and then they can easily connect or have the similar ideology or similar principle, and they can have the connectivity. So they will have the information. These data center people, these data center region, these data center employees have the complete information on this particular data center, and the other will have in this Hyderabad AWS data center employees have the complete information about the Hyderabad region. So this way they can share the data and they can have the or if connectivity or whatever the requirement from one country to other region is required. So this is the other reason for having this multiple regions in the multiple locations. So and these are some of the regions that where the AWS data centers have been established or created. So and this is about the regions. So in the very next section, I'll just walk you through the content, or I just brief you on the overview. I'll just brief you on the content that will be complete covering on this complete training of AWS, so that we'll come to know what services and what mm, cloud platform services that we use in the AWS and all. So that's for today. Like have a great day, and like we'll meet in the next session with the content that we continue that the content that we cover in the complete training, com- this complete training. Thank you all.